middle school, for the first time you guys used Pythagorean theorem to find a missing side, right, in a triangle. Okay, and you had to be given two of the sides, right? And then you could find the third using Pythagorean theorem. You could plug in for two of the three, A, B, or C, and then find whichever one was missing. But that only worked for right triangles, and you had to know two out of the three sides. Okay, so then we stepped up our game a little bit when we got into geometry, and then we were able to use opposite, hypotenuse, and adjacent sides with sine, cosine, and tangent. And then you were able to find missing sides or angles, right? You can use those to find either one. And you don't have to know two of the three sides necessarily, right? But still, only was for right triangles. Today, we're going to use law of sines. And law of sines can help us find missing sides and missing angles, but not just for right triangles, for any type of triangle. All right, so it does not have to have a right angle in it in order to use this method. All right, so first they just kind of explain to us where it comes from. So here, this line, that would be considered the height of our triangle, right? So when they use H right here, they're just referring to the height. They're talking about this line right here. All right, so remember sines ratio. Remember we have this to help us remember our ratios. So sine comes from this one. Sine is equal to opposite over hypotenuse, right? Okay, so they said sine of angle A. So that'd be this angle here. Again, remember this only works for right triangles. Luckily, the height when drawn in gives me a right triangle, right? Okay, so sine of angle A is equal to opposite, which would be the height, right? The height is opposite of our angle, over the hypotenuse. The hypotenuse would be this side here, right? Okay, they're calling that C because it's across from angle C. So angle C is here, so side C is across from it. Okay? Then they also said if you're doing this for C, so angle C, then opposite of angle C would still be the height, right? And then this would be my hypotenuse. Well, that's across the figure from angle A, so I'm going to call that side A, which is what they set up right here, right? They said sine of C equals the height over side A, or the opposite side over the hypotenuse. So all they did was set up sine for the two right triangles that are drawn here, okay? It then says that you could solve for H. Well, in this equation right here, if I wanted to solve for H, how could I get rid of the C that it's being divided by? Multiply. Okay, so I could multiply this side by C, and then I'd also have to multiply this side by C, and then those would divide out, right? And that's what would give me this right here. C times sine of A equals H. Okay? Same thing over here. If I wanted to get H by itself, all I would really need to do is multiply both sides by A, right? Then my A's would divide out, and then I'm left with this right here. A times sine of C is equal to H. Okay, well, we can use the substitution property, or just if you think about it, what we're saying here is if this is equal to H and this is equal to H, that must mean these two things are equal to each other, right? If they both equal H, they have to equal each other. So that's what they did here. They took this piece, and they said those two things have to equal each other if they both equal H. So we've got C times sine of A is equal to A times sine of C. And then it says what they want you to do to get from this step to the next step is divide both sides by AC. So let's do that. I'm going to divide both sides, this piece and this piece, both by AC. Okay, Well, over here on the left side, there is no lowercase a in the top, but there is a lowercase c, so those two would divide out, right? And on the right side, what can I get to divide out? Right, that lowercase a. So we end up left with sine of a over side a is equal to sine of angle C over side C. And that is our law of sines. Okay, so your law of sines says whatever piece you might be looking for, whether that's one of these angles or if you're looking for one of the sides across from that angle, all you have to do is set up a proportion. You don't need all 6 pieces. All you need is one complete fraction. So if I know A and A, but I don't know the angle B, but I do know the side B, I would just set these 4 up in a ratio, cross multiply, and solve for the piece that's missing. Okay? So you only are going to have to set up 4 pieces or 2 fractions, set them equal to each other, cross multiply, and solve. So now that we know where it comes from, let's look at an example. It says here, find all missing parts for the triangle given. Okay, so I don't necessarily know what this triangle looks like, but I'm going to give myself a little sketch of a triangle just to keep all my pieces straight. Okay, so I'm going to label this angle A. This is angle B, and I'll name my top angle C. Okay, and remember that across from the angle, we label that the side. So if this is angle B, across from it is side B. And across from angle A is going to be side A. And across from angle C is going to be side C. So we'll use uppercase letters for the angles, lowercase for the sides. All right? Okay, so now I'm going to go in and label what we were given. So they told us angle B is 30 degrees. So I'm going to put that in my triangle. They told me angle C is 45 degrees. And then they said side B is 9. So this side over here where we put B is 9. Okay, so if I look back up here at what we said our law of sines was, remember I said you just need one complete ratio. So you need to know both A's or both B's or both C's. Which one do we know both of? B. Right, I know B is 30 degrees, and then I know side B is 9. Okay, so I am going to use that as my first ratio. So sine of B, which is my angle, they told us was 30 degrees, right? Over the side B, which is 9. And then I'm just going to set that equal to a ratio where I'm looking for another piece, okay? Well, we know angle C is 45, but do we know side C yet? Okay, so let's say we're looking for that. So then I would set this equal to sine of angle C, which is 45 degrees, right? And I would put that over side C. That's the part I don't know, so I'm going to leave it as a variable. So that's the only variable left in this equation. I just need to solve for it. So what would be my first step to solve here? Right, we're going to cross multiply. So I'm going to multiply this direction, and I'd have C times sine of 30 degrees is equal to, when I multiply this direction, I'm going to have 9 times sine of 45 degrees, right? Okay, and our goal here is to get C by itself. So right now, C is being multiplied by sine of 30. So how could I get rid of that sine of 30? Divide. Okay, so I'm going to divide both sides by sine of 30 degrees. So those would divide out. And then I just need to go type that in my calculator. Now, all of my angles were given to me in degrees, right? So what mode do I need to make sure my calculator is set in? Degrees. So double check, make sure your calculator is in degree mode. And then type 9 sine of 45 divided by sine of 30 in your calculator. Either put the top in parentheses and the bottom in parentheses, or use that alpha y equals enter function so that you keep it separate. What do we end up with there?
12.7.
Okay. It didn't say where to go. We're going to go to the thousandths place here on the note. So we'll do 12.7. What would that be? 28? Yeah? Okay. All right, perfect. Okay, so we found side C, but it said to find all the missing parts, right? So we now have this piece, this piece, this piece, and this piece. What am I still missing? The A's. Okay. Well, in a triangle, what do we know all the angles add up to? 180. And do we know 2 of the 3? So what could we do to find the third one? Right. Okay, so angle A could be found by taking 180 degrees and subtracting out the 2 angles that we do know, which are 45 and 30. All right, so if we subtract out 45 and 30 from 180, what must angle A be? 105. All right. So now we know angle A is 105. So I found that piece. So there's the second thing we found. Now all that's left to find is side A, right? So I'm going to set something up exactly like I did here. I can even keep this first part the same, right? I can use sine of 30 degrees over that side 9 is equal to, this time we're looking for side A. So I'm going to do sine of angle A, which we said was 105. And I'll put that over side A. And what should I do to solve? Cross multiply. Okay, so this direction I've got A times sine of 30 degrees is equal to 9 times sine of 105. Then what should we do? Divide by sine of 30. Good. All right, and what do we get for A?
17.387.
Very good. All right, so we were given 3 pieces, and we have now found the other 3 pieces. So we found everything that was missing. All right. So for law of sines, all I have to do, guys, is set up a ratio, okay? But remember, one of the ratios has to be completely filled out because I can only solve for one variable at a time, right? So make sure whichever one you put in the first fraction that you have both pieces of it, all right?